Hello, hello everybody. Good morning in Chile. Here we have 11 o'clock in the morning. Um, my name is Denise Lagos. Today I will be your virtual tour guide around La Silla Observatory, and I'm with Felipe Zurita in the background. But today, Felipe Zurita isn't have a good microphone, so forgive us for that. But Felipe Zurita will be read your message, your great welcomes are all that in the comments. So today we will start around the Silla Observatory, and it's, it's important to say to you that the La Silla Observatory is in Chile. So, Felipe, if you can share, thank you so much. Well, La Silla, first of all, La Silla is a place that is in La ESO corporations. I have 16 uh, state members, like you say now in your screen. For example, Denmark, the Netherlands, United Kingdoms, Ireland, Belgium, France, and all the European countries that you see in your screen. Also, they have Australia like a partnership and Chile like a hood state. Okay, Chile is uh, Chile share with the ESO members, ESO states, share his earth, okay, in Atacama Desert. So that is very important for LAESO because they can they yes they can build is its observatories in the desert in the desert of Atacama in Chile. Okay, so in Chile we have these observatories facilities. Excuse me, I need to take some water. In Chile, we have these observational facilities. For example, Paranal in Atacama region, like Armazones is the future of the ESO building now. It will be start 2030. And we have Chagnantor too. Is there Alma, and before that is it will be their Apex. So these are the important in the region of Antofagasta, the important observatories. Then in La Silla is in the fourth region, okay, in the end of fourth region in Chile, in La Coquimbo region. Is very important La Silla because um, it's very important La Silla because there is the first observatory that La ESO built in 1970. Okay, so the first telescope that La Silla have here in Chile is the ESO 3.6 meter telescope in La Silla. Okay. So the next we will start to travel to La Silla Observatory. So, like you see in your screen, we will start in Germany, in the territory of Germany, to South America, and we will travel around our Earth, and we arrive in exactly in Atacama Desert. Okay, we wait that this travel around our planet is coming to Atacama Desert. So now we are in Chile, and then we will fly over La Serena Observatory in this when they start in the Coquimbo region, like that you see now in your screen. We have the Danish Observatory 0.5, and the Danish and another Danish Observatory 1.54, and these are extra observatories. Is there are for France, for is built in French, and ESO 2.2 meters, and Observatory Smith of 1 meter. There are the NTT, is another important telescope in the first building in 1970, and the Sweden and the Tarot is another French telescope, and there is the visitor center when we uh, uh, receive that the people that coming to see La Silla Observatory. So now we are in the place that you can see is La Silla Observatory, and all that is around La Silla Observatory in Chile. That is the beautiful view like that you see. So here, yes, we have there the sea, the ocean, and here we have the CEST. Is the first antenna that work with the radio wavelength in South America. So here we have the other part of desert, the Cordillera de los Andes height, and here we must be in to 3.6 observatory. So here we have in the 3.6 telescope. Is a very very big telescope, and have that like you see. Good morning from Nashville, Tennessee. Hello, Nashville, Tennessee. From Amsterdam. Okay, thank you for seeing us from Amsterdam. Greeting La Silla team. Thank you so much. We are from La Silla team too. Okay, so sorry about this message. Was very grateful. Okay, so ESO 3.6 metro telescope that you see there inside to this big dome, and that, like you see there, you see two colors, okay? Two colors in the telescope. We have the blue and the light blue, okay? The blue is the equatorial mount. That's very important because the equatorial mount that is sustained at the old part of telescope, okay, all that around the telescope. For it is too big, this telescope, that you can see the little person there down to the telescope. So this is very, very important because a person show us that the how big is that this telescope 3.6. So this telescope have two mirrors. Okay, we have the primary mirrors is in the middle. Yes, like the Felipe show us where is it, and the second mirror is the up, is up. Yes, just there, and this cylindrical cage. Okay, uh, so all that's in light blue is the telescope, is the part, very important part of telescope when we catch the light, and then the light it has processed around the between 10 or 5 minutes in our instrument harps, and the harps is too important like the instrument. Okay, so the harps works with the wavelength, with this old rotation, for example, around the planet, around the star. Okay, here we have the center star, and around there have a planet. Okay, this planet uh, we can see in the wavelength like this planet have a gravitational push to the star. For that, this our wavelength this move to left and right because this meaning that the star have this push in the planet. Okay, because the star have more gravitational force than the planet. Okay, so like you can see in your screen, this is the gravitational force is show us this all this draw behind the rotational planet that you see in your screen, and all that meaning that the planet is around the star. So a parenthesis is you need to read your comment or leave us your comment. Uh, Leave in the case to write your comment because we are right to you. Okay. Hi from the neighborhood, from Argentina. Argentina, I was born in Mendoza. I have been there in La Serena. It's such a beautiful place. Thanks for showing us incredible work. Eres de Argentina, Karina. Hola, hola, ¿cómo estás? Qué bien que estuviste en La Serena. So I say that hello, Karina. It's so good that you could be in La Serena in this region. It's a beautiful region. So excuse me about my voice because I have allergic today, so that I have this voice. Okay, imagine that what Galileo will think. Oh yes, yes. It's a good it's a good comment. Okay, so okay, Karina, good. So now, Bob Dia. So now Felipe show us around the La Silla Observatory, around the 3.6 placement. So now Felipe show us NTT uh, telescope. That's, that is a first telescope in the world that is work with a different pieces of mirror. Okay, so NTT means a new technology telescope. Like you say in your screen, we are inside to the NTT. So look that it's so big. Here we don't have a person in the behind the entity, but it's so big like the 3.6. Yes, we have this, for example, this door is an example to how big is the telescope. And this telescope, like that I say before, is a, a telescope have the new technology in 2011, 2010. Now it's not a new technology because the other telescope that ESO building now is with the same engineering about the mirrors, but this telescope was the first using the zero dur mirrors. Okay. Yes, thank you, Felipe. Is show us where is the first mirror or the primary mirror is building like the zero dur alation, chemistry alation. And what is the zero dur? What is zero dur? The zero dur is, for example, that you have in your kitchen and your oven when you cook your food and have another and only one plate that you put your uh, I forget the word. When you put your I when you put your all your need to cook your food, your pot, when you put your pot in the kitchen, this is this new kitchen that you have only one plate. uh, this is with a vitroceramic too. So this Cerodur is a vitroceramic too. Okay, so there is the first mirror and have a big difference like the 3.6 because in the entity we can see the mirrors. So Felipe show us in the high. Yes, there is the mirror. is the open that you can see when you come into CS to La Silla. You can see the mirror, and the second mirror is up. And when the yes is there, when the Felipe show us is the second mirror. Okay, so this telescope works with two instruments. Okay, there in this door we have the one instrument. Its name was SOX, but today we don't have nothing there. But before that, it was working SOX instrument. Okay, in the infrared wavelength, and in the another door, uh, now is a FOX instrument. The FX instrument uh, work with a visible wavelength and infrared wavelength. Okay, so like you can see here, if Felipe show us up in the top to the yes, thank you, in the roof. Okay, we can see we have the open the doors. This like you can see is this door is a big door that they open side by side. Okay, so this telescope have two movement. It have 3.6 movement, 3.6 degrees, and have the second movement is up and down. Okay, but in this telescope, when turn around the 360 degrees, is turn around the all building. All big building is turn around on 3.6. So, okay, and we must continue to this tour. So we have okay, so here, where is the astronomer? You can see where is the astronomer here in this telescope. So before I told you that here don't have a astronomer when we compare the size of this telescope, but where is it? Maybe you can write us in your comment, where is it? So this is a room, a control room of astronomer. But that, like you see, it's a big room. So where is it? Is in the same building of NTT? Is in the same building to telescope, or is in another buildings around the telescope? So the good answer is is in another room. Okay, is another control room outside to the telescope. So here, for example, in that you see the people have the different color of clothes. So the color cloth people is astronomers, and the dark cloth is operators. These operators works in control the movement of telescope in ESO. So we are, like you see on your screen, we are in the middle of the room. So if you see to your right, you can see is the only 3.6 controls. And the left part of the room, we have the entity controls, okay? So let us your comment, please, your regards and all that, because we are reading you. So we have the next part. It's an interesting part because we are show you the top 10 of the best discovered from the ESO astronomers. So give it to come to see us to La Silla and come to see the top 10, the best discovery from the ESO astronomers.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when two independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, so do you like the video? I hope so. So now that do you see in your screen? Here are in the night in La Silla telescope. Is there a time of the year to telescope see better the sky from La Silla, or what that happens on? That's a good question. Because yes, here in Chile we have a good night and a good time to see the sky, but the original idea for build a telescope in the desert of Chile, it was because in the desert of Chile have less rain in the year and have less cloud in the year. But that's not don't mean that we don't have any. We have rain and we have cloud, but less than the other part of in Chile and less than other part in the South America. Okay, so yes, we have a good time in the year. For example, summer. For example, spring. That's a good time to see the sky. But in the winter or in the autumn, we have another star in the sky. So on another, we can see another places in the sky because the Earth is rotation all the time. I have translation too. So for these two uh, these two time to Earth, this we can see different part in the sky and different part in the Milky Way, our galaxy. Okay, so I hope that I can answer your question, Karina. So here we have another question. So as four telescopes work together in BLT, can other telescopes do the same, gathering light from La Silla, Las Campanas, Tololo, and many others? I'm sure it's not easy, but maybe yes, can help. Well, here we have a good question, because it's meaning a lot of answers. So I will try to resume this answer. So excuse me, I take some a little water. uh, okay, La Silla Observatory don't have the same gathering light like a BLT. Is work different. Okay. Um, Las Campanas, Tololo, and other telescope works with another technology. Okay, because it depends that the instrument that the telescope is looking for in the sky. Okay, that is a big difference, because, for example, is in Alma have telescope like this telescope, for example, La Silla? No, don't have, because Alma have antennas, and antennas work with only radio wavelength. Okay, and the radio wavelength means that we can looking for another bodies in the sky, like a black bodies, for example the black holes, for example the dark nebulas, and all that is a different that the other work that they have, and they do another telescope. BLT have the same gathering light, uh, because the technology is work like in this way. They share the light and do some artificial star in the sky for the best position of of this telescope. For that, the BLTs work different. It works different to La Silla, or works different to Tololo and others. Okay. Well, Las Campanas and Tololo is a collaboration for another countries too. Okay, for that, La Silla, Las Campanas, Tololo is not in the same ESO. Okay, Las Campanas is a part of Las Campanas Carnegie. Tololo is part of Noir Lab and have another partnership countries. Okay, that is a good difference that I say you too. Okay, so Sergio, thank you about your question. I hope that I answered well that, and I hope you that you have a now have a good idea for that. Okay, so we are continue. We must continue for this tour, virtual tour around NTT La Silla Observatory and the telescope that you see. So here have the one of arm of the Milky Way, and now we are near. Felipe show us near to the arm of the Milky Way. We have the Orion Belt. Okay, we have here the Orion constellation, and in the middle of the Orion Belt. Here in Chile, we say Las Tres Marías. In Spain and in Europe, they know that the Orion Belt, like the Los Tres Pastores, me parece. And here in constellation of Orion, we have a good star, for example, Rigel, Betelgeuse, and all that star that are investigated around this last year. Okay, so here we have a Sirio in the Can Major constellation. Okay, Sirio is a big star. Okay, and this star is yes, is this is there like show as Felipe. Sirius is a big star, and is a star that have a lot of investigation to the scientifics here in Chile because have a different have a so different uh, different works uh, to the other stars in the near to the Milky Way. Okay, so now have the our satellites galaxies have the small Magellanic Cloud and large Magellanic Cloud, and here we have a view of the Milky Way. Okay, this arm of the Milky Way, and Felipe showed us the large Magellanic Cloud have a lot of nebula. Okay, the nebula are important because in the nebula is when the star born. Okay, is where the star born there. So is the nebulous island is like a maternity around of the stars. So here are in the middle of the Milky Way, our bulge, where is the, for example, another dark nebulas or dark parts in this arm. So Felipe showed us, for example, La Yacana. In the when the indigenous was living here in Chile, they see this dark part in the nebulas and they put nine names there. For example, La Yacana, for example, the hunter, for example, the snakes, and another draw that they saw in the sky in the past. Okay, so they the indigenous say in the past that the Milky Way is a river and the other animals come to drink water. Okay, so Felipe showed us the river, this big river, and the animals that you can imagine in and the dark part. So here we are, this bulge. Okay, then when we have our black hole, and so this is a good picture in the night because you can see the all that figure and this draw in the animals there. So now we are we go to see the South Cross or Cruz del Sur. Uh, South Cross is the our constellation in South America. This show us, Felipe, where is the cross? Yes, there is it. It's our South Cross. So we can see the South Cross in another hemisphere. For example, in the North Hemisphere, we can see the South Cross. You can see the South Cross only in the South Hemisphere. The South Cross is have a rotation around the South, only in the South. Yes, this rotation that I show you, Felipe. Okay. Yes, Felipe, thank you so much. This rotation and this way to the right way have the South Cross constellation. Okay, all the year. All year, the South Cross constellation is rotation around the South. So we have a comment for Facebook. Clouds stay low below to the telescope. Uh, sometimes, sometimes we have clouds below to the telescope. So, so did you see there that you can see there the yellow lights? Look that, do that yellow and green lights in there. What's the meaning to these lights? This light meaning pollution light. This is the city pollution lights. So these pollution lights are very important to try to be far away to this pollution light, because the pollution lights don't help to work well. Okay, because like you see there, the pollution light have a lot of interview in the margin. So, for example, if the telescope, if will try to see a star when the pollution the pollution light is there, we can see that because the pollution light have a lot of interview and a lot of light, of course, that the picture result and the imagine result is not so well. So that we have to fight to in we must fight for the don't have a pollution light near uh, to our telescope on our observatory. Okay, so we have another comment. It is true that exists stars that do not have a spectrum of colors like the one who is in the sun. Hmm. Okay. The stars that don't have a color spectrum um, is the death of a star. For example, the white dwarf, the brown dwarf, and all that star that is the part of the death of a star. Okay. Sometimes happens that we have a binary system. Okay, binary system means that they have two stars rotation about around this two star. Okay, they this binary system have their own masses of center. Okay, so there are rotation around between these two stars. When happen that the one of these star have more light than another star. Okay, that don't mean that the another star don't have light. That meaning that you can see only the moon shining star. Okay, only that. But if, for example, the astronomer investigate around the star that don't have a spectrum of light, uh, this star maybe is the death of another star. Okay, the death of a star is the black hole too, and the black hole don't have light, any light. Okay, and this is important part too of the death of a star. But the star, if this star have more, is a big star of masses that have a big masses star. When this star died, uh, this star died in the black hole. Okay, this is important. So we are in the finally part of this tour, virtual tour, and now we uh, we can show you the hotel here in La Silla Observatory. So here we have our photographer. Have they take photo to these beautiful places in the night, in the day. This there is it. This our photographer. So now, like you can see, we can see the middle of the Milky Way up in our roof in the 12. It's a good picture. Enjoy to the picture. Enjoy us to the picture. So, uh, okay, this hotel this work all year. It's a private hotel for the astronomer and scientific and all engineering worker that they work hard every day to have the telescope a good maintenance all the time. Okay, so now we are in time to say goodbye. I hope you that you enjoy our tour. So sorry about my voice because I have a lot of allergy today. And so like say in your screen, thank you to attend the tour. So and thank you to your comment too. And are it's a very time that we can read all your comments, but in another tour we can read all that. So share us uh, share us this tour guide with your followers and all that, please. So bye bye and bye, Felipe.